Boop. Oh, that was stupid. Business time. All right.
What did you do?
Oh, the usual.
You went to the pumpkin patch?
No, I did not go to the pumpkin patch. I went ice skating and had a couple of family dinners, watched the Jays game, you know.
So you didn't fly?
Huh? Didn't fly, nor did I go to Portland. All right. Have I been to Deschutes Brewery? No, I have not. Have I enjoyed the Deschutes Brewery products? Yes. Well, okay. All right. So, all of you are aware of the three trigonometric functions that we have been dealing with, and they are all encased in SOHCAHTOA. So far, we have only dealt with up to 90 degrees, and we have only barely touched on the fact that the universe is indeed divided into 360 degrees. We have done all of our work over here. Yes? Okay, so we are going to extend that to the entirety of a circle, and then we are going to extend that to performing trigonometric functions on triangles with angles greater than 90 degrees. Okay? That's the end goal of this. Now, I've told you already, this is only maybe a third of where you can go with trig, even what we're going into right now. There is much more trig to come, but you guys will be very well positioned for IB after this unit. So, quick reminder, we all know it's been 3 days off though. How do we illustrate the sine ratio of a given angle, theta? What do we use to do that?
Opposite over hypotenuse.
Exactly. We have opposite over hypotenuse. And what is cos? Adjacent over hypotenuse. And what is tan? Opposite over adjacent. Now you guys are aware of all three of those. You're quite comfortable with them. But we are going to, as I said, expand that from where we have started. All right? Now you guys all recognize this construction. This is the Cartesian plane, yes? The Cartesian plane, excuse me, has a couple of things on it that you remember from the 9th grade. This, of course, is what? The x-axis. This, of course, is what? The y-axis. What is this spot right here? It is 0, 0. It also has a name. What is it? Does anyone know? It is the origin. Some of you may have heard that word before. Some of you may not have. All right? Everybody Gouda? Okay. What do we call each of these chunks of the Cartesian plane? Do you know that word? Yes, indeed they are quadrants. How do we name those quadrants? How have they been named? Does anybody know that? Nope. Pardon, Tiffany? Roman numerals, yes. 1, 2, 3, and 4. Where is quadrant 1? Top right corner, quadrant 1. Where everything is positive, yes? All right, and then we go, now this is where it gets confuzzling, because we go counterclockwise, okay? So this is quadrant 2, this is quadrant 3, and this is quadrant 4. Everybody's cool with that? This isn't news to anybody, right? Right? Okay, now, in this quadrant, in quadrant 1, x, y, our coordinates are always positive. Cool? Okay, so what are they in quadrant 2? X is negative, y is positive. In quadrant 3? Negative, negative. And in quadrant 4? Positive, negative. Okay? Everyone is cool with that? This is all background. You already know all this stuff, yeah? Everything is hip? Everyone's good? Okay. Now we're going to do a little bit of vocabulary. Now that everybody is comfortable with this, everybody is aware of how the Cartesian plane works. You've had your mind brought back to it. Everyone's cool? Okay. So, let us move on, cabbages. Cactuses. Dummy. An angle is in standard position. Please highlight it, underline it, do whatever you need to do. Okay? If the vertex is at 0, 0, okay, and the initial arm, all right, is the x-axis. Now, initial arm is a new word or a new term for many of you, I hope. So let's go back up to our plane here, and let's put that in. I'm going to use red. There is the origin, and now I'm going to draw the initial arm. It is on the x-axis. Everyone cool? What's the other way it could go? It could go to the left. Everyone all right with that? As long as my angle starts there, it is in what we call standard position. The other side of the angle, because do I have an angle yet? No. The other side of that angle is what we call, the other ray forming the angle is what we call the terminal arm. Oops, that was going to be the terminal am. The terminal arm. And that makes sense, right? Initial, where you start. Terminal, where you end. Everybody okay with that? So we're going to take this and we're going to finish this angle and we're going to draw it out into quadrant 2. All right? So here is my initial. Here is my terminal. Now, sadly for us, the math guys are not standardized because math guys didn't get along with map guys in the past. On a map, what is at the top? North. And what degree is it?
0.
0. And what direction do we go when counting? Clockwise, right? Never eat soggy wieners, right? Everybody good? You probably learned never eat shredded wheat. Never eat soggy wheat. Oh, you mixed them both. Interesting.
Never enter Santa's washroom.
Never enter Santa's washroom. Yeah, especially not on Christmas Day because he's been working really hard and he's probably saved up a big one. I agree. All right. Okay. Beryl, I know North American kids can't remember 4 things without something like that. I just remembered Northeast, Southwest too. But, you know. Anyway. Of course, more interesting. Remember the story of the hippopotamus. My grade 7 math teacher told me if I couldn't remember the word for the hypotenuse, I could remember it as hippopotamus. And then I wrote on my test hippopotamus, and he gave me 0.
What?
I know, right?
What you meant, though.
I know, but that, Bronwyn, is why I never have fun little stories about princesses swinging through castles to rescue somebody, and that's why I tell you what the math words are, so you don't have a hippopotamus. What?
What if we want a hippopotamus for Christmas, though?
Then you're crazy, because hippos kill more people than anything else. Everyone's so worried about rhinos.
House hippos.
No.
Yeah,
Although I really like that commercial because that's proof of how gullible or how ungullible you guys are unless you're gullible, right? Like all of you that honestly thought 23 people were killed in Canada by clowns over the last week. Until you went to the bottom of that website And it says right on the screen, this is a satirical website. Everything on here is a lie. And yet I had countless students, oh my God, Mr. Myers, the clowns are real. There's been 23 people killed in Canada by clowns. Oh my God, I saw it on the internet. Oh God, I'm so scared. I'm scared too. The fact that you people couldn't read. That scares me. Anyways, back to business. Everybody cool with this? Everybody knows how they count on a map? All right, now forget how they count on a map. Because in math, they count differently. Okay? In math, they count like this. All right? Counterclockwise. It's hard to say. Counterclockwise. Or, of course, if you're in Britain, anti-clockwise. Yes, anti-clockwise, which, of course, makes clockwise uncle clockwise. Anyways, counterclockwise is positive angles. And clockwise is negative angles. And get this, we don't start counting at north. We start counting at the x-axis. What? Oh my good gravy. What a pain. He's just finished teaching us northeast, southwest, and now he's teaching us this. Yes, imagine that. The world is slightly complex, and you may have to learn more than one thing about it. Sorry. I've already taught you to read the disclaimer on your web pages. That's lesson 1 today. The global sun isn't real. That was the name of the website that was reporting that 23 people were killed in Canada. It sounds like a newspaper, doesn't it? The global sun. Yeah, it's not real. Just like people get mad when they read stuff in The Onion. They're like, oh my God, did you see The Onion? Yeah, I saw The Onion. I know that it's a joke. But whatever. So, remember, we are now not thinking of northeast, southwest. We are now thinking of angles. Okay? So where do we start counting? Right here is 0. All right? When we go this way, anti-clockwise, it is positive. When we go this way, uncle-clockwise, it is negative. Everybody understand? But other than that, the dimensions stay the same. So if this in direction is 0 to 90, what is this in angles? 0, and what's this? 90. And what's this?
180.
180. And what's this?
270.
270. Everybody with me? So now, what would be a good estimate of this angle if we were to measure it? I start here. I go positive, and what would you think that would be? 130, that's fine. The point I'm trying to make is you recognize I've gone past 90, but I haven't gotten to 180. Is everybody good? Okay? So we're going to say, 120 degree estimate. Is everybody comfortable with that? Are you? Honest and for true? Okay, now you guys do ABCDEF should be on the top of your next page. Sketch those angles. You can talk to your neighbor. You can discuss it with him or her. It is up to you. Please do not talk to your neighbor 3 houses over. Please talk to your next door neighbor if you are going to talk to your neighbor. You can go to your neighbor's house, but try to bring a cup of sugar or something so it looks like you're actually going for a reason.
Or hey, you could bring that bottle of sugar. Sorry.
No, you're bringing your chair. No, I didn't say you were moving furniture.
Here's the sugar.
This literally should take 10 seconds. ABCDEF.
It's all.
Remember, it's just estimation. None of you need to get out a protractor. Why do you think I'm getting you to do this? So you get used to where the angles lie. When you are done A, B, C, D, and F, A, B, C, D, E, and F, I want for you to give these a shot. You should have room to sketch them on your page. G, go for negative 75 degrees, and H, go for negative 95 degrees, and see what you come up with. When you finish A, B, C, D, E, and F, try G and H, which I have right up on the screen as negative 75 and negative 95. All right. That should be enough time. If you are feeling lost, watch, and maybe it will become elucidating. 30 degrees. Where do I start counting? On the x-axis. It's positive, so where do I go? Up. 30 degrees, boom. Anywhere in there, I'm happy. Okay? Everybody good? Okay, where's 135? Halfway through the second quadrant. Excellent. Where's 245? In the third quadrant. Down here. Because I count this way. 65, first quadrant, steeper than the first one. 285, all the way around to here. Ooh, look, I made a snail. I have a snail-shaped pancake mold. I make pancakes and snails and butterflies, because that's the molds I have. I also, for my son, have a Millennium Falcon, an X-Wing fighter, and a TIE fighter. No, I didn't. And 115, a steep one up there. Is everybody good with regular old easy positive angles? Okay, how do I do negative 75 then? I got to go down. So it's down here, yeah? Everyone agree? Please notice something about negative 75 and G and E. What do you notice? They're in the same quadrant, so you can have a positive and a negative angle ending up in the same spot. Do we all understand that? Excellent. And negative 95, where would it be? Second quadrant? Third quadrant, because I got to go 90, but just a little bit past it. Is everybody good? All right, I'm not going to ask you to draw it, but use your brain. What if I wanted an angle of 400 degrees? Where would it be?
Second quadrant.
Halfway through the first quadrant. Why? Exactly. All the way around takes me to 360, and then 40 more. Everybody good? Now that's not going to come into play until next year. I just wanted to see if, I'd given you enough information to make that inference. Everyone good? To draw 425 or 400 just for fun, it would look like this. I'll do it in red. You would go all the way around like a snail, stop there, and that's what it would have to be. Cool? Everybody good? So if it was 780, I'd have to go around twice and stop at 60. Got it? Okay. Next thing. All of these are what kind of angle? They are in what position? Standard position. Why? They started at X, and there's a terminal arm. Got it? Okay, now, most of you are very intelligent young people. I lie. You're all very intelligent young people. I'm just being a funny guy. All of you should recognize something. Look at B. Look at B. And tell me if there is more than one easily measured angle there. There is, of course, isn't there? There's the 135 that we started with, but where is there another angle that would be easy to deal with? I can go around the other way, which is 360 minus 135, but I can also go right here, can't I? Is everybody with me? This is what we call the reference angle. And I'm just going to write ref there because I'm about to define it right down here. Given an angle in standard position, the reference angle. Now, what does the word reference mean? When I say I'm in the reference section of the library, or I'm using you as a reference, what does that mean in English? You can go back to, and it helps you, right? If I'm using Christina as a reference, somebody's going to phone her up, and she's going to say, he's pretty funny, but he can be a bit of a dick, right? You picking up what I'm putting down? Of course, you're not actually allowed to say that, but not about me, about anyone. You can't give references that way. It's illegal. So, yeah, it is. All you're legally allowed to say is, yes, that person worked here. Technically. Everybody does it, but you're technically not allowed. So you should be careful, because if you do find yourself in a boss position and somebody calls for a reference and you are like, that guy was so bad, I can't believe it, and he finds out about it, you could be in a lot of trouble.
So you have to say they're good?
No, you can't even say they're good. You can only say they worked here for that amount of time.
Oh, really?
Yes, legally.
It's just not any personal
Yes.
ideas.
I know, it's weird, but legally that's all you're allowed to do.
Makes sense.
Anyway, so yes, you go back and refer to it, right? Now, if I were doing SOHCAHTOA with you people, could you do SOHCAHTOA on 135 degrees? Yes or no? Why? Because it's not a right angle, right? And it's bigger than 90. So we're in trouble, aren't we? But you guys are smart kids. If this is 135, what's this? 25. Do some better addition. What's this? 45. She said 25. Oh, but she said 25. Okay, so now, could we do SOHCAHTOA on 45? Yeah. So since they're at the same angle, can we not do SOHCAHTOA on 135 as well? Because they're the exact same spot, aren't they? Is everybody with me? Okay. So that's the next thing we have to discuss. We know what a standard position angle is. We know what the terminal arm is. We know what the initial arm is. Well, the last thing we need to know is the reference angle. The reference angle is as follows. The angle between, and this is hard for a lot of kids to get their mind around this. The angle between the terminal arm, that looks like all one word, terminal arm. The terminal arm and the x-axis. Please highlight x-axis. So many kids, when they're doing this, start using the y-axis because the line is close to it. It's not. It has to be the x-axis. Okay? So, I'm going to do exactly what we did in the first one. I'm going to put 4 degree numbers here. I want you to draw the angle and its reference angle now. Okay? So the first one we'll do nice and easy for my girls right here. 160 degrees. Okay? Everybody good? Yeah? Everybody happy? Happy, joy? Yeah? Okay. So, where is 160 going to be? Second quadrant out here. There's the 160. Where's the reference angle? To the x-axis. Right here. And how big is that? 20. Nice job, Bronwyn. Way to recover. Everybody good? Yeah? Easy peasy lemon squeezy, right? Okay. Let's go with 299 degrees. Mr. Myers. That's crazy, though. It's crazy. Where would that be? Fourth quadrant. So we're going to go. Now, where is the reference angle? It's right in here. Oops, it didn't go red. How do I find it? Why is it 61? Because that's 360 minus 299 to get 61 degrees. Is everybody cool? All right. Let's see. 137.5 degrees. Why, Mr. Myers? Why must you do this? Because 17 years of math teaching, and I'm so tired of hearing, I can't do that one because it looks different. Where would it be? Second quadrant. There's the 137.5. So what's the reference angle? 42.5. Yes? Why? 180 minus the 137.5. Is everybody good? See how I did 180 degrees there? I know, right? Visual aid. Good teachers model different stuff. All right, now I'm going to mess with your heads. 35. Draw it and tell me the reference angle. And what's the reference angle? It's also 35. Why? The angle between the terminal arm and the closest x-axis. I didn't write closest. I wanted to see what would happen.
Oh, I thought you said closest.
I might have said it, but I didn't write it. Everybody cool? Yeah, it's closest. Everybody good? What do you notice about every single reference angle? Look at the 4 we've done. You guys are smart kids. If it's happened 4 times in math, it's probably going to happen a lot of times in math, yeah? What do you think is a statement you can make about the reference angles?
They're less than 90.
Yeah, the reference angles are acute. And if you don't remember what acute means, it doesn't mean you want to take it to the prom. It means it measures less than 90. Okay. Now, don't get me wrong. If you want to take an angle to the prom, you're welcome to. Just be kind of hard to find a dress for it. Nothing? It would have to be a cute one. All right. You guys do ABCD. Draw each angle and do the reference angle all by yourself without me talking. Which, as you all know, is next to impossible for me. And when you think you've got it, someone come up, take the magic pen, and do it on the screen while I go get tea water.
All of them?
One of them.
Oh.
Do the first one, it's the easiest.
Magic pen? Wow. I don't know how this works. I don't want to mess anything up. I'm just in case I do the math wrong.
I'm just doing the first one. Wait, if I touch my hand to it, does it draw on it? Oh, it doesn't. Whoa! This is intense. Do you like that straight angle right there? Shh.
Yeah, up top! That was weird. It was not the same hand.
I know.
I know, we nailed that
We
one.
really did.
Yeah.
I can't even get a good one with people with the same hand.
You confused me that one.
So she's absolutely correct, isn't she? Would anybody else like to come up and do another one and use the magic pen?
Oh, yeah.
It's not as easy as one might think. It is fun. It's a good time. You didn't use any color or nothing.
Well, I don't know how to do that.
Oh, all right. That's because you're not old. You don't know you got to dip your pen in the inkwell here. Haven't you seen Anna Green Gables?
Yeah.
They're remaking it, eh? Yeah, new. Yeah. All right. So B. Where's 120?
Second one.
Out here. There's the 120. Reference angle 60. 250. Third quadrant down here. Right? Reference angle 70. Because I go back up there. 70. So it's 180, 250 minus 180, right? 350. All the way around to here. But then back to the nearest x-axis, 10. Is everybody good?
I need to come back.
Great!
Ah.
Grate, because you grate cheese. That's why I always say, are you Gouda? Great! It's not Tony the Tiger. It's grating cheese.
See, when you said it the first time, I was waiting. I was like, oh, so right?
All right, now. Whoa, 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 whoa.
You can say, do you like tigers? Great.
I could do that. Now, in your previous incarnation as math students, what did we use to count on the periodic table? On the Cartesian plane. I just had a bunch of grade 9s in here at lunch, and they were doing balancing chemical equations, so we were talking about periodic tables. And as you are well aware, I am gray-haired and rapidly declining. So, what... What did we count on the Cartesian plane? We never counted angles. What did we count? Grids. It was the coordinates, right?
Yeah.
3, 2, 4, 7, right?
Yeah.
So now we're going to put grids and trig together. I know, right? Do any of you watch New Girl?
No.
Never watch. None of you watch New Girl? Well, then that joke was totally lost on you. All right. Now, read this question. Draw the angle in standard position if this point is on the terminal arm. So,
Hey, that's not a question.
It's a statement.
Yeah, you gotta put a question there.
Can you or may you?
Oh.
no names mentioned. We won't talk about who it was. Christina, can you do this? He asked questioningly. Can you do this? See how I raised my voice there to get to the interrogative? Yeah, interrogative. That's a lot of syllables. Yeah, bring it. All right. No, seriously. Seriously. This point has to be on the terminal arm. Where does that point live?
On x-axis.
Out 3. And what?
Up 2.
Up 2. So there is my angle. Is everybody cool with that? Everybody's got it?
Yep.
Okay. Do that for all of these. Go. You got 5 seconds. I'm just kidding. You got longer than 5 seconds. You already did it because it's easy, right? -5, -1 down here. Sim sim salabim. 2, -4. 2, -4 down there. Boom. -10. Boom. 5. Boom.
Oh.
Right there. Oh, somebody stop me. 4, 2. Right there. Wah. -4, 2. Wah. -4, -2. Wah, wah. And 4, -2. Wah. Now, smart kids, right? Right? This is when you say yes. Smart kids, right? Bronwyn. Okay. Smart kids, yeah? What do you now have here? What have you made? An angle. What can you add to this to do some trig now? Make it a triangle. Slunk. And what do you have here? How far? What is this? 3. What's this? 2.
Oh, wow.
Oh, wow. What did we just do? Trigonometry. If that's theta, what did we just do? What did we make?
Angle of elevation.
Angle of elevation. So we got an opposite and an adjacent, don't we?
Yes.
Badass. Now, so drop this to the x-axis, making what angle? No.
Angle of...
It makes the reference angle, doesn't it?
Yeah.
So the reference angle becomes theta, and what do we know about that theta?
Angle of...
How far is this? -5. How far is this? -1. Somebody stop you guys. What about this one? Make the reference angle. How far is this?
2.
2. How far is this?
-4.
-4. Make the reference angle. How far is this?
-10.
How far is this?
5.
+5. Make the reference angle. How far is this?
4.
How far is this?
2.
How far is this?
-4.
How far is this?
2.
How far is this?
-4.
How far is this?
-2.
How far is this?
4.
How far is this?
-2.
What does that tell you about the relationship between coordinates and tangent? What do you already know about tangent?
It's opposite over adjacent.
Agreed? Everyone agrees?
Yep.
Okay. So in angle A up here, what's the tangent of it? 2/3. Yes? Oh, wait. I'm a dummy head. Sorry. The tan of theta is 2/3, correct?
Yes.
Everyone agrees? Great. What is the tan in B of theta?
-1/-5.
-1/-5, which is what? We'll just leave it like that for now. Trust me on this. Just wait a second. We'll come back to that. C. What is the tan of C?
2/4.
-4/2. And what is the tan of D?
5/-10.
5/-10. Now, please look at what I am about to highlight. What is the connection between my coordinates, my opposites and adjacents, and my tangents? Tan is not only over A. If the angle is in standard position, what else is tangent?
Y/X.
So for E, tan theta is also y/x, which is what? 2/4. F?
2/-4.
2/-4. G? -2/-4. And H? -2/4. So now, not only is tangent opposite over adjacent, it is also what? Y coordinate over X coordinate. When? What is the condition here? What does the angle have to be? When the angle is in standard position. Is everybody cool? Yes? Yeah, everyone is Gouda? Great. Okay. Take a moment.
No, it doesn't leak. It's just.
Please label the little Cartesian plane with its quadrant numbers first. Everybody good? All right. Now, next, on the big Cartesian plane, and I will have to shrink mine down a little bit to get it all on the screen at once. On the big Cartesian plane, sketch a circle that joins the arrows. Okay, I get to make a perfect one because I got me a sketching tool on here that makes things, if it works, which it isn't, so embarrassing for me, right?
Oh. Like around.
It looks like an oval.
It's close enough. All right. Everybody is sketched in a circle? It doesn't matter. It really doesn't. It's fine.
It's kind of sketchy.
This is, oh yeah! Sam's circle is kind of sketchy.
I just made it look like that. Right before you did that.
Well, it's not me that you have to seek credit for. It's Sam. All right. So this is what we call the unit circle. And we call it a unit circle because The radius is, no, the radius is 1.
1.
Okay?
Always?
In the unit circle, yes. Which means this point right here has what coordinate?
0, 1.
Other way.
1, 0.
1, 0. What is this point?
0, 1.
0, 1. What is this point? -1, 0. And what is this point?
0, -1.
0, -1. Is everyone cool with that? All right. That is the unit circle. And the unit circle is the basis of what we're about to do. Okay, everybody understands this? Now, you guys are smart kids, and Case has made this case a couple of times in this class. When we were talking about right angle triangles, Case talked about, well, they're all 3, 4, 5. Right? Remember that? And what did you mean by that, Case? The ratio is always 3, 4, 5, right? Even though the numbers aren't 3, 4, 5, the ratios are 3, 4, 5, right? Everyone is good? So in this case, with the unit circle, that's kind of the basis. Like the 3, 4, 5 triangle is the basis of Pythagoras. The unit circle is the basis of what we're going to do here, right? So if this is the unit circle, its radius is 1. But can we shrink or grow that circle? Yes, of course we can. If I make this circle bigger, then what is going to change here? The x or the y coordinate? If I stretch this circle, well, circles, if you stretch in one direction, they stretch in all directions. But if I stretch this circle this way, which will automatically stretch it this way, what will change here? The x or the y? The x is the only thing that's going to change, right? So this point on every single circle is x, comma 0, isn't it? What is this point on every single circle?
0x.
No. 0, comma y, because the y's are changing. What is this one going to be?
-x.
Negative x, 0. And what is this one going to be?
0, -y.
0, negative y. Is everyone cool with that? Yeah? Okay. Everybody on your big Cartesian plane now, draw me the following angles in standard position. Okay? Everybody good? Ready? Ready? Okay. 50. Where would 50 be? And we're going to start with just 50. It would be somewhere out there. Is everybody comfortable with that? Is everybody comfortable with that? So here is our theta, and our theta equals 50, yes? Everyone agrees? Yep. Okay. Now what we just did, this point right here, has two incarnations. If that point was on the unit circle, then how long is the radius? 1. Is it a positive or is it a negative?
Positive.
Why?
It's not positive. I mean, it's going counterclockwise.
Well, that's the angle that's going counterclockwise. You're getting warmer. You've actually jumped a step, Danielle. You have inferred where I am going with this. Why is this positive 1. Think about what positive and negative means. Getting warmer. It has to do with moving. Where am I going from?
The x-axis.
No. Where am I going from? The
origin.
origin. And am I moving away from it or towards it?
Away.
Away from it. And away is designated to be positive. Is everybody cool? So this is 1 on the unit circle. But you guys are smart kids. If it's positive 1 on the unit circle, what is it on every other circle? Do you know? No. So what do we give it in math if we don't know? A letter. Can we give it X? No, because we've already got X's in this construction. Can we give it Y? No. We've already got Y, so it has to be a different letter. We're going to use, what would be a good letter to use for the radius of a circle? R. So this is also R. And what is R? Positive. Y. R is the radius, and it's always positive. Because it's a magnitude. Now, some of you are going to be saying, but Mr. Myers, there's 4 quadrants. You're not fooling me. Eventually, you're going to draw 3 more lines, 3 more terminal arms. And those R's, I'll get back to it in a minute. Those R's are not going to be pointing in that direction. So how can they still be positive? Has that crossed any of your minds? Sure it has. Don't be that way. Don't sell yourself short. Okay, good. Don't write this down. Three, 4. How long's the hypotenuse? Why? Don't say 3, 4, 5 triangle. Why? How do you know the hypotenuse there? A squared, B squared, C squared, correct? So that is the A squared, B squared, C squared. It's Pythagoras, yes? Okay, watch. So this is the square root of 3 squared plus 4 squared, yeah? What is 3 squared? 9 plus what is 4 squared? Everybody got it? So it is the square root of 25. Everybody cool?
Yeah.
Watch. Now what's the hypotenuse?
-5.
Think about it. What is every hypotenuse? Square root of the leg squared, right?
Yeah.
What's -3 squared?
9.
Positive. What's -4 squared?
16.
Positive. So the square root is still positive. Hypotenuses have to be positive because of that. Everybody with me? All right. So, you guys are very intelligent young people. I keep telling you this even though you don't seem to believe me. Why would I lie to you? What then? You already know that this point right here has what value of y? Do you know? So what is it? It's a letter, it's y, and is it positive or negative? Positive. What is its value of x? Do you know? What is it then? Positive x. Is everybody cool? Do I now have a triangle? With what sides? X, Y, and R, yes? Now, go up to that little chart we had at the front or at the top. What do you already know about sine, cos, and tan? Before today, what did you already know? What is sine? O over H. What is cos? A over H. What is tan? O over A. Now, what did you just learn about tan? It is also what? Y over X, correct? Okay, what's cos? What's adjacent here? X. And what's the hypotenuse? X over R. And then what is sine? Y over R. Everyone got it? So now all of a sudden we can do trig using the Cartesian plane with just coordinates. How does this help us? Well, if we have a map, maps are cut into coordinates, right? So you guys are smart kids. Everybody draw for me now 130. I'm going to change colors and do 130. Where would it be? Right there, correct? Can I do trig there yet? Not until I do this. Now, what do I have? Do I have an R? Sure I do, because it goes from the center out to the edge. Is it positive or negative? Why? Because R is always positive. Why? Because of Pythagoras. As soon as you square something negative, it becomes positive. What is this distance? No. Negative x. What is this distance? Positive y. Great. So now, in quadrant 2, what is sine? Y over r. What is cos? No. Negative x over r. What is tan? Y over negative x. Wait a minute. Now draw me 230. Where would it be? Which I will draw in green. Make your line. Is negative x still there? What's this? Negative y. What's this? R. So what then in quadrant 3 is sine? Negative y over r. What is cos? Negative x over r. What is tan? Negative y over negative x, which makes a positive. And finally, in black, it doesn't matter, just draw it. What's this? Negative y, what's this? R. Now go back up here and finish your chart. What's sine in the fourth quadrant? Negative y over r. What's cos in the fourth quadrant?
X over R.
X over r. And what's tan in the fourth quadrant? Negative y over x. Now using that information, sine, cos, and tan can be positive or negative, can't they? Does everybody understand that? Because all we've done is taken SOHCAHTOA, right? And moved it around the triangle, around the plane. Positive, positive. That's what you're used to. Did we do any changes? We still have an opposite and adjacent, but now they've got a direction because we're on the coordinate grid. Everyone cool? So, on this chart right here, which of these is positive in quadrant 1? Quadrant 1 is the blue. Are they all positive? So we're going to write an A there because they're all positive. What's positive in quadrant 2? That's the red. Which of these is positive? Sine, cos, or tan? Sine. So sine is positive there. What's positive here? Tan. 2 negatives. And what's positive here? Cos. And it spells a nice little word because everybody needs acronyms. CAST. C-A-S-T. Well, you could also say ACTS if you want to go clockwise. You could say whatever you want. The point, I don't use that at all. I just know that signs are positive in quadrant 2. But if you are the type of kid that needs a mnemonic device, Abel was I ere I saw Elba. There is one. Is everybody cool with that? Now, I call your attention to the fact that we are now letting go of SOHCAHTOA. And we are embracing X, Y's, and R's. Why is this good? Because as soon as you know the coordinates, you automatically know the SOHCAHTOA, don't you? Do you have to draw the triangle anymore? Oh! Why are we excited? Why are X? Bronwyn, ladies and gentlemen, Bronwyn. She'll be appearing here all semester. Tip your waitress. Now, you guys already can do this. You can do SOHCAHTOA now without a triangle. Because what is this? That's X and that's Y, isn't it?
Yeah.
So what is the sine of this theta? Cos of theta and tan of theta. Theta, or sine, according to the chart we just did, is what? Y over R, correct? Right? Y over R? Okay, so what's the R here? Well, you just got to think about it. It's on the terminal arm. It's right here. 4, 0. What's the R? 4. Right? So, what's the Y? 0, because sine is Y over R, and it's 0 over 4. So what's the sine? 0 divided by 4, guys. 0. Okay. What's the cos? Cos is X over R. Oh, not 4, dummy head. X over R. What's R?
4.
What's X?
4.
So it's 4 over 4, which is? 1. What's tan?
0 over 4.
0 over 4, because tan, I forgot to write it, is Y over X. 0 over 4. Everyone good? Pardon me? R and X are the same number? Not always. In this case. Now what about this one? What's my R? Pardon me? How do you know which one what is, Victoria?
How do you know which one R is?
R is, okay, you have to visualize, right? So here, I'll shift this down a little. There's your Cartesian plane, yes? Where is 0, 3? Right there, correct? So there is my R. How far up did I go there? 3, because that's where I would make my circle. Okay? That's why we drew the whole big circle here.
I didn't get that. I didn't get that part.
Okay.
I'm gonna be honest. Yeah.
What?
You were like, but we drew the whole thing to get R, but we don't get it when it's like that, but we get it when it's like this.
So once I drew this, what you're saying is you're good now.
Yeah, now we're good.
Okay. You needed to make that connection. Okay. All right. Now but you guys did know that because in a circle, all the R's are going to be 3, right?
Yeah.
So even if I go diagonally there, that still has to be 3 because it's a circle, right? Everyone's cool?
Yeah.
Okay. All right. So what is sine of theta in this second one? Sine is y over r. So what is it? 3 over 3. Cool? What's cos? Cos is x over r, which is 0 over 3. And tan is
3 over 0.
y over x, which is 3 over 0. Are we good?
Yes.
Are we good? All right. You guys try the next two, because I feel that maybe I've screwed you over somehow. Where is the negative 5, 0 to find your r? It's right here, yes? So what's my r? Not negative. R can't be negative. R is 5. So what is the sine, the cos, and the tan? Sine theta is y over r. I'm just going to put in the fakes. Now you guys fill in the numbers. What's y here? What's y here? 0. It's right there. Y is 0. R is negative 5. So, oh yeah, sorry, R is 5. Thank you. And x and r. Negative 5 over 5. And tan? 0 over negative 5. Everybody cool? And finally, what is this one? You shouldn't even need to draw it now. You shouldn't even need to see y over r. Sine is negative 2 over 0. Cos theta is 0 over 2. And tan theta is negative 2 over 0. Everybody good? Okay. Now, I am going to be mean and see if you guys can take what we just talked about and do just number 2. That's your only work for today and your only homework. I am not going to tell you how to do 2. You have all the tools you need to do to figure out number 2. That's your homework tonight. And you got the rest of the period off. I will have your quiz marked tomorrow.